one with brackets, one with parentheses. What else? Yeah. Mhm. Good. So the intervals of continuity is where it's breaking the graphs, exactly what you said. Domain is looking at the big picture. Okay. The breaks can be holes. They could be officially breaks. It's where you have to pick up your pencil. Okay. No matter what, that is intervals of continuity. So for A, this first one, what would the domain be? What would the domain be for A? I'm sorry, I tried to make it pretty dark. Yeah, Jonah. Good. -2 with a bracket, because it's a closed circle, to infinity. What would the range be? Luce? Excellent. -4 to infinity, again with a bracket, because it's included, and it's the lowest point. Okay, and for those that couldn't see it, that was a line going through. All right. What's the domain for this one? Yeah, geez. Excellent. -5, 5, parentheses because of the open circle, and bracket because of the closed. How about the range? Julia? Okay, and what would be around them? Good. I heard my name, but I don't know. It was like a ghost. Anyway, so closed circle overrides an open. Okay, so this is correct, both with brackets. -2 to 2, even though it's an open circle here, it is included on the right-hand side. So no matter what, it is a bracket. Okay. All right. Now our factoring for A. What do we have? Isabel, go ahead. Careful. Careful, careful, careful. It's what multiplies to this and adds to that. Is that what you had written? Did you say that? Oh, you did. I'm sorry. It sounded a little. I heard -9 and 1. I'm sorry. Good job. Good job. Okay. -8 and -1. I'm sorry. Uh, yeah, I heard something completely different, but nice job. All right. How about B? Good job. B, Luz, go ahead. Good. Okay. Any questions about B? Are we okay? Factoring wise? We're good. Okay. Now we have inequality. We want to write it in interval. How would I write this in interval notation? Liv, go ahead. Good. Excellent. Bracket around -8 because it's equal to, parenthesis around 16. How about B? Patty, go ahead. Okay, what's around them? Good. All right. How about C? Luce, go ahead. Excellent. Great job. Okay, so remember the or is that U, where the interval is continuing. Okay, so there might have been a break in the graph, whatever it might be. -infinity, -3 with parentheses, U, 4 with a bracket, to infinity. Excellent. Okay, now, what is the domain? Jason? Careful. Roughly. There is here a hole in the graph at -3.5. Okay, do you guys see that? Might have been a little difficult, but negative infinity to negative 3.5, parenthesis, right? Negative 3.5 to infinity, okay? So your domain okay? Why we don't break it again is because there's a point in terms of the domain, okay? So as you're going through negative infinity to negative 3.5, there's a hole here. There's nothing below it or above. Yeah, Isabel. It is the whole thing. It is the whole thing. However, there is a hole here. Okay, so it's not included. So looking at the whole graph, I still included 3 into my domain because there's a point here, as opposed to here where there's not. There's no point above or below it to count it, so to speak. Yeah, Anton? It would be negative infinity to negative 3. So union, there's more to this one. There's more to intervals of continuity, okay? So every time there's a hole and or break, looking at the graph, you're going to have intervals. Here, there wasn't any additional. There was no point above or below. If there was a point here, then it would be negative infinity to infinity. But since there's not, I have to include that as a separate interval. Does that make sense? Okay. Most of the graphs we have seen were just jumps, right? Where you're looking at the full picture and it's negative infinity to infinity. Here, there is a hole right here with nothing, no x value being used. So if I asked you f of negative 3.5, it would be undefined, right? So you could jot that down to remember. F of negative 3.5 would be undefined. However, f of 3, which I should have included, would be what? Approximately 2.1 or 2 point whatever you wanted to say. Okay? Why wouldn't it be 1? Go ahead, John. There's a hole there. Okay? So maybe by seeing this, it would help you a little bit more, knowing what's included and what's not. I know this is tricky. I know it's tricky to know the difference between domain and continuity. Okay? So some cases, the domain, which we saw in one of the examples last class, was the same as the interval of continuity because there was a hole in the graph. Okay? Which I'll go back to show you in a minute. So for the intervals of continuity, everywhere we see a hole and or a break, even though there's a point here, we are going to include it. Okay? So we have negative infinity to negative 3.5. Negative 3.5 to where? Negative 1, good. Then where? Good. And then? Good. Okay. So look at even the difference between that, right? There's more intervals with every break, as opposed to the domain only took care of this hole here. Okay? All right. What would the range be? Julia? Excellent. Good. Negative 2 to infinity with a bracket. All right. F of negative 1 would be what? F of negative 1. Yeah, man. Negative 2. Good. Because of the solid circle. All right. F of x equals 1. Addie? Careful. Mm-hmm. Okay. So if we did a horizontal line, okay, at 1, at 3 it's undefined, however, at about negative 4 it's included. Okay? So be careful. Those are the ones that trip us up a little bit. Okay? Yeah. Yeah. You could. You could. I don't want to say never. You could if there is a jump in the graph. So say if there might have been one on the homework or one on one of the reviews or one of the practice problems we did. I'll go back to see, but there will be, especially if there's a gap in between. Yeah. Right. Always parentheses. Okay. All right. Let's finish off at least the last two. All right. This one, apologize. Hard to see. What would the domain be? Let's see. Julia. Good. Negative infinity to infinity. What would the interval of continuity be? Isabel. Yep. Mhm. Mhm. Keep this sheet on your paper right now. Turn your over to nope, this one. All right, keep a look at this one, and I'm going to bring you back to here. Okay? The difference between the two, this was, say, a solid line, right? And we had jumps, which you have in the second graph. Here you have a circle, an open circle, which means this value of x is not included in the domain. Okay? But if this was a whole line here, okay, with no open circle, the domain would be negative infinity to infinity. Okay? Just because there's a hole, negative 3.5 is not included. Okay? So that's the difference between if we go looking at this one with the hole right here, no other point, compared to this one where if I scan across, negative 2, yeah, it's an open circle, but it's included up here. And if I keep going, 1 is an open circle, but it's included here. So that's why it's part of the whole domain. Okay? Great question. Interval of continuity would be what? Caitlin, what do you have? Mm-hmm. Mm-hmm. Excellent. Good. Great job. Okay. How about the range? Ellery, what do we have for the range? Good. Negative 2 to infinity. Excellent. Okay. F of 1. Belle, go ahead. F of 1 is 2. Good. Let's look at the other one. F of x equals 4. Oh, and what do we have for that one? Good. Good. Okay. F of x equals negative 1. What do we have? Yeah. Excellent. Good job. Great job, guys. Any questions? Are we okay? And this is the last graph we'll do today, so we can move on. Okay, we'll get to those a little bit later. All right, for number 6, what is the domain? Julia? Good. What is the interval of continuity? Go ahead, Luce. Excellent. Good. All right, negative infinity to negative 1, where there's a jump and you're lifting your pencil, and then negative 1 to infinity. What would the range be? Go ahead, Julia. Careful. Careful, careful. Go ahead. Careful, careful. Look at the whole graph and something to the right. Okay. All right. Luce? Careful. Yeah, Owen. Why? Okay. We had, I think, maybe the same one on the practice, but negative infinity to 4. Excellent. Okay. Negative infinity to 4. All right. Just be careful of that arrow. All right. How about f of negative 1? Yeah, Jonah. 1. Good. F of x equals 4. Would be, yeah, Anton. 3. Good. And then f of x equals 2. Yeah, Jason. 0. Anywhere else? X equals 0, and then I go all the way across. So this is the value you gave me, right? 5. Good. Excellent. Okay, good. All right. So we'll get to 7 and 8 a little bit later because I want to get into the rest of the characteristics. So when you're doing the domain, okay, again, big picture, you're looking from all the way to the left to the right. Make sure every x value is being used. If it's not, that's where you have to split for the intervals, okay? Interval of continuity is taking your pieces of graphs, whether it be a hole or a jump, and splitting it, okay, into pieces, all right? Today, we are adding to our notes. So if you could take out your notes from last time and turn to page 6, okay? All of these fall under the category of characteristics. And I think you guys have seen these before. Increase, decrease, way back when? 2 years ago, maybe? Okay. Notes. All right, so a few things that we're adding to characteristics besides domain, range, and intervals of continuity, okay? We're going to look at the x and y intercepts, which we have seen, okay? Then we're looking at intervals. So one thing you're going to notice, anytime we see that word, intervals, we're using parentheses, okay? Intervals of continuity, intervals of increase, decrease, or constant, okay? So anytime a graph is increasing or decreasing or constant, we're looking at the x values, okay? Then we have, this is also called extrema, where it just refers to local or relative maximin as well as absolute maximin, okay? So one thing with local and relative maximins, it's your turning points. It's where you're going from increase to decrease, decrease to increase, okay? Absolute minimum is the lowest point, okay? Lowest point. So in this case, we have an absolute minimum here, okay? But what you don't notice, do we have an absolute maximum? No, because we have arrows heading to infinity. Infinity is never a max or min. Never, okay? Infinity is never a max or min. We're always looking for our y values, okay? So you could have a relative min and an absolute min, okay? You can have that like you see here, okay? Same thing with the maximum. But again, maximums and mins, you could have multiple. So you're just listing the y values, okay? And we'll see that in a little bit. And then increasing and decreasing, you're reading it from left to right. I like to do from starting from the left of the graph, explain what's happening, then keep going in pieces, all right? So it's up to you if you want to use, when we get to increase, decrease on some of these things, if you want to use different colors, one to represent increasing, one to represent decreasing, and one for constant, that sometimes helps. Or you could just jot down with your pencil as you go. All right? So we are first going to do, we have the graph to the right. I want you to try A, B, C, and then the f of negative 1. Okay? Try those 4 right now since we've been doing those. All right. So f of 3, what do we have? F of 3. Go ahead, Isabel. 2. Excellent. F of negative 1. Julia? 5. Great. Excellent. F of 0. Yeah, Jason. 6. Good. Okay. Then for what value is f of x equal to 0? Yeah, Jonah. Good. Excellent. Okay. Negative 2.5 and negative 6. Awesome. Okay. So for C, what would this be labeled as then? What's another word we could use for these? Yeah, man. X-intercepts. Good. These would be your x-intercepts, okay, which are typically written negative 2.50 and negative 60. What would B represent? 0, 6. Julia? The y-intercept. Excellent. Which is typically written 0, 6. Okay. So 2 things that are kind of new. If we see f of x is greater than 0, what does that mean? What would that mean? What do you think then? F of x also means what? Y. Okay. Keep that in your mind. Where would it be on, like, the graph, let's say? What? Sorry. Yeah, Mia. Above the x-axis. So this means when y is positive. Okay? So we're looking for intervals of when y is positive. So, I said above the x-axis. So would this piece right here be considered positive? Y value is positive? Yeah. Would this piece here be considered positive? Yeah. So we're going to write those as intervals. Bless you. So since it says greater than, we're going to have parentheses for this one. Okay? So we have negative infinity to where? Yeah. Negative 6. Good. Okay? So negative infinity to negative 6. Okay? Because once we reach, after we cross that x-axis, we become negative. So we're using our x-intercepts to help. Okay? Then from here to wherever, that's also positive. What is this x-intercept? Yeah. Yep. Negative 2.5 to infinity. So between negative infinity and negative 6 and negative 2.5 and infinity, our y values will be positive. Okay? God bless you. So this notation then means our y values are going to be what? Negative. So from where to where? Hello, I gotcha. I gotcha. Okay. So from below the x-axis, right? So from where to where? What's happening? Yeah. So what we just did is from here to here is positive, okay, where y values are positive. From here to here is also positive. So that those two are intervals of where your y value is positive. And we're using the x-intercepts because that's where it crosses over from positive to negative, okay? Then we go to, from here to here is our negative zone, okay? But if you notice, did we include the domain? Did we just take the domain again and split it into positive and negative? Yeah, again. So we're using our x values again, okay? Our x values are going to be used throughout this whole thing in terms of increasing and decreasing, okay? All right, we're going to stop right there. All right, what is the value of f of 0? God bless you. Jason? F of 0, good. -4, awesome. F of x equals 2. What would it be? Sorry. F of x equals 2. What would it be? Yeah, Jules. F of x equals 2. What are the x values for that? Oops. 3 and 4. All right, what's the domain? Luke? Good. What is the range? Jason? Good. Okay. Intervals of continuity. Same or different? Same. Good. Okay. Y-intercept? Yeah. 0, -4. How about the x-intercept? Okay, Jules? -1. Good. Awesome. Yep. You could have more than one x-intercept. There's only one y-intercept. All right. Any questions about the following? Pretty good, right? Okay. So now we're looking for intervals of increasing and decreasing, okay? And again, looking at the x values. And we're always going to use what, since we have the word interval? Parentheses. Excellent. So, again, we're taking the full domain and looking to see where the graph is increasing. So, if we go across, looking at it, from here to here, what's happening? Increasing. And then from here to here, what's happening? Increasing. So when we write that interval, okay, interval increasing, -infinity to -1, union 0 to about 3.5. Okay, that's where it's increasing. Now, some of you might say this little piece here looks like it's constant, but it's not. If I was to expand this graph, it's still increasing. That's called an inflection point. So even if you see this, no matter what, it is increasing. Okay, so keep that in mind. All right, now we're going to look at from here to here, what's happening? And then from here to here, decrease as well. Okay. So, how would I rate the intervals of those two pink areas? Where is it decreasing? Yeah, there's
-1 to -4.
X values.
-1 to 0. Okay.
Perfect. Good.
And then 3.5. Oh yeah.
Infinite. It's okay. It's okay. It's all getting used to this. Okay, it's all getting used to us. Now, one thing I want to make sure you understand is you want this to match. Okay, you want this to match. So if I'm using 3.5 for increasing, I have to use it for decreasing as well. So even if some of you might have done 3.2, let's just say, you have to use that 3.2 to describe the decreasing as well, okay? So these have to match because what's happening is you're taking the full domain again and splitting it into intervals of increasing and decreasing, okay? So then the next notation, f of x is less than or equal to 0. So that means where the graph is what? What are we looking for? The y values are what? Yeah. 0 or what? Negative, right? So, again, we're looking at intervals. So where are we, what x values make the graph negative? Yeah. To 0, you mean? Where are you looking? Here? Yeah. Okay. We would use 0 as our x value. Okay. We're using our x values. X values. You have one segment. Where else? Yeah. Okay. 4 to what? Okay. Anywhere else? Yeah. Okay. Good. Anywhere else? Yeah. So where it's less than 0, where your y is negative, okay, we have negative infinity to, you could even include all the way to 2, but since it hits 0 and then comes back down, technically 0 is not positive nor negative, correct? 0 is not positive or negative. So we have negative infinity to negative 1, union negative 1 to 2, union 4 to infinity. And I actually have to put brackets around these. I put brackets because it's less than or equal to. Some might say you could also jot this down, but it's incorrect. This, okay, the reason it's split, and you could ask any AP teacher, x-axis is not positive or negative. So when it hits the x-axis, you have to split it into 2. Okay? Questions? So overall, increase, decrease, positive, negative, you're just looking at the x values. Again, describing the domain. You're describing the domain in pieces. Again, okay? So intervals of continuity is looking at the pieces, but now we're describing again. Increasing, decreasing, positive, and negative. All right? Okay, so now, yep. So what I want you to try on your own with your partner, I'll give you about 3 minutes. Domain range, continuity, increase, decrease, constant, x and y intercepts. Go ahead. Yeah.
When you did negative 8 to negative 1, would there be a bracket around the
If I had both brackets here, it would mean it's not a function. So one has to have a parenthesis, one has to have a bracket.
So could you do the negative 1 with a bracket and the other next one with a
Either way. So great tip there. You could either do this or like that. Okay? Go ahead. Try these. All right, you guys, domain. What would the domain be? Yeah, Isabel. Perfect. Good. Negative infinity to infinity. Okay. And here's where you're going to see a difference with the range. Okay. You guys have smiles on your faces. Go ahead. What do you have? Good. Excellent. Negative infinity to negative 1. Union. Bracket. 0 to 4. Okay. Nice job. So the reason it's split into 2 is because this space right here, there's no y values being used. Okay? There's no y values being used. The x values are being used if you look left or right, but if you go from bottom to top, here, there's a space in the graph. Okay? So do we see that too with, I think Julie asked that question before. Okay, continuity. Oh, and what do we have?
Negative infinity.
Uh-huh.
Negative 1.
Yep.
Negative 1 to 2. 2 to infinity.
You could include that because that's a solid circle there. So negative infinity to negative 1, correct? And then just go through the whole thing. Okay? Negative 1 to infinity because that's a solid circle, so it's just including. Okay? All right. Increasing. Where are we increasing from? Yeah, Eddie. Use the x values. Yep. 0 to 2. So increasing is from here to here, and then that little piece there. Okay. Where are we decreasing? Where are we decreasing? Yeah, Isabel. Excellent. Negative 1 to 0. We are decreasing right there. And last but not least, where are we constant? Spectrum. 2 to infinity, which is this little piece here. Okay? How many of you did get the increasing, decreasing, and constant? Okay. Where did we have a little hiccup with that? Yeah, Isabel. The range we had a hiccup with. Okay. Which expected because we've seen one other before that, right? So when you're going bottom to top, just scan it. Use your pencil if you need to. That, until we get our eyes around some of these graphs, will make it a little bit easier. Yeah.
Wait, I don't understand how linear
Left to right.
so it doesn't matter about the arrow?
No. So when you're reading it left to right, okay, and that's big confusion that I see a lot. When you read it left to right, this is an increasing line. If it was decreasing, it would go this way. Okay, so don't let the arrow trip you up. When you're looking left to right, this is still going up. It's just a piece of a line. Okay, yeah. Bill?
So you also have raised brackets.
Right. So let's see, let me do it differently. So increasing, decreasing, constant, continuity, depending, okay, if this is just less than or greater than, you would use parentheses. Okay, so all of these are parentheses, interval. Okay, all right. Loose question?
Never mind.
Okay, all right. So Julie, I think you might have asked this before someone did in terms, or was it you as well? It was you? Okay. For the range where there's a gap in between. Okay, just keep an eye for that. What are the x-intercepts? What's the x-intercepts? Yeah. 0, 0, good. Therefore, what is your y-intercept? Okay. All right. So this notation here means f of x is greater than or equal to 2. Okay? Greater than or equal to 2. So 2 is here. Now they're using 2 instead of 0. Where do we start? What x value would be greater than 2? Greater than or equal to 2. Yeah. Yeah. Okay. So since it says greater than or equal to, we use approximately 1.3 to where? Yep. Excellent. Okay.
Wait, where did you get the 1.3?
If you look at f of x is 2, right? Here's about 1.3. If you said 1.5, that would fit too. Where the graph? The arrow. All the x values. Okay? Where it's greater than or equal to positive 2. Okay? Questions? All right. The note regarding extrema, it is your max and mins. Okay? This has arrows too, by the way. All right. So, anytime you're looking for local or relative, those are two words you'll hear. Local min or local max, those are your turning points. So that's from increase to decrease, decrease to increase. Okay? Local are your turning points. So, where do we have minimum values? Let's look there. Kind of hard to see, so it's an estimate. What do we got? Hey, Joe. -3, okay. Anywhere else? Yeah, Eddie. So you're looking at the y value? Yeah. -0.2 would be your local min. So here's a min, and here's a min, okay? Where would be a local maximum? Looking for turning points from increase to decrease in the y value only. Abby? 0. Okay, so local min, decrease, increase. Local max, decrease, nope, increase, decrease. Okay, so a hill you're looking for. Okay, local min is the valley, as they call it. All right, now the absolute minimum, okay, without any arrows, would be your lowest point, lowest y value, which is what? -3, good. Do we have an absolute max? No, because we have arrows, okay? Because of the arrows, okay? One thing with maximums infinity, like I said before, is not included, okay? Let's look at B. Local minimums would be what? And this is -100, -120, -140, -160, -180. Yeah. -170. Good. Where else? Anywhere else? Yeah.
-3.
Y value.
Oh, 0.
Good. Excellent. Okay. Any local max? Julia? Yep, 40. Okay. Any absolute minimum? Yeah, any. -170. Good. Any absolute max? No, because of the arrows again. Okay, good. All right. Yeah, honey. Okay, so this is after going through all lessons regarding x values. This is where it switches to just y. Okay, so your extrema are your y values. Okay, extrema are your y values. Okay. All right, so now we are going to tie it all together. Okay, you have your function notation, A through D. Then you have intervals of increasing and decreasing, domain and range, local and relative minimum, maximum, absolute min, absolute max, x and y intercepts. Okay, you got it? Go ahead. So, kind of kicked myself because I wish I did it a different way than I've done years and years and years. Okay, so increasing from here to here. So it's not exactly on that -4, right? So if you said negative infinity to -3.5, -3.8 approximately, you're good. Okay, yeah.
Okay, I missed a
-3 is right here.
Oh, okay.
So just be careful. Again, just be careful. This is practice. This is what it's all about, right? So then we have negative infinity to -3.5, okay? Then it's not exactly on -1. All right, well, you could say -1.2-ish to 2, okay? So again, same ballpark. You are, just look at the graph a little closely, okay? So negative infinity, -3.5, union, -1.2-ish. Whoa. We're good. We're okay. Okay. Now decreasing. Okay. So here's where I'm glad it actually showed up. Right? Again, two separate people did these problems, right? But we should have, and again, if you put -4 here, you should have -4 here. Okay? Not changing it to -3.5. I'm just saying. If you had originally -4, so Olivia, for you, see if you have -4 and -4 here. Good. Okay. So you want those two to match. All right. So from decreasing, on ours here, we have -3.5. I'm going to use what I have on the board to -1.2. So we have to make sure it matches what I have above. Okay. Then we have 2 to infinity. Okay. So keep that in mind. So again, good. We'll just change that. 3.5, and these two matched here, but again, you want to be pretty precise. Okay. Then the domain is correct. Negative infinity to infinity. The range, negative infinity to to +5. Awesome. Would the interval of continuity be the same? Yeah, it would, right? Okay. Now we're looking at the relative min. Okay, we have about -5. Some of you might have said -5.5-ish. Which I would go at -5.5 here. Yeah.
Okay, I missed it.
Just as okay as -5. So where is it? You guys look. Look at the minimum. Hi. Okay. All right, so we're going -5.5 as our minimum. Okay, our local minimum. -5.5. Okay. Local max. 1 and 5. Absolute minimum. None. Good. Absolute max is, this should be 5.5 too. Oh, nope, 5. Sorry. Okay, x-intercepts we already went through. Y-intercepts, 0, -2. Awesome. Good. Okay, so one thing from today, and we're done for today. We're going to get into practice. It was a lot of information in terms of characteristics. It's a lot. It is a lot. when you try to tie it all together. But remember, increasing, decreasing, constant are looking at your x values. The extrema, maximum, absolute, maximum is your y values. Okay, domain, x values, range, y values. Intervals of continuity are your x values again, but splitting the graph into pieces. All right, and then we have x and y intercepts, which we know of. Your homework is in the practice, okay, 1 through 7. And actually, I want you to try A2 in terms of absolute value equations, if we know how to solve absolute value equations. Not really sure about that. But definitely 1 through, the numbers are mixed up.
The last 2 pages.
Last 2 pages, that's it. And try the absolute value equations. Yeah. Okay.